then now the boiler that's online is going to backfeed steam into the boiler with the tube failure. As the name kind of implies, it's essentially a check valve. But specifically, this term gets used a lot in the boiler room, and a non-return valve is a stop check valve. Well, what's a stop check valve? So it's a check valve that I can also close manually with a hand wheel. So in many cases, this is like a globe style valve where the stem of the valve and the plug are not joined together permanently. So if I unscrew the stem all the way, then the plug can move up and down as a check valve, as like a plug style check valve. But if I screw that stem all the way in, I'm forcing that non-return valve closed. Now, do I have to have a non-return valve? You actually don't. So the code requires when I have two high pressure steam boilers on the same system that they both need to have double block and bleed. So I have to have two stop valves and an ASME free blow drain between those stop valves, so that if I have a boiler down for maintenance and another one online, I can double block and bleed that boiler that's down for maintenance and ensure that no steam backflows onto the professionals that are inside that boiler doing work. So it's really a life safety concern. So we can do two gate valves with a bleeder gate valve in between. That's allowed. Why is it though that it's so common that we see non-return valves? Well, from what I've been able to find in the research and in the industry knowledge, the brains I've picked, whatever, the non-return valve is really a safety feature. If I have two boilers online and one of them has a tube blowout and develops a really intense leak, it will bleed down the pressure that boiler was creating, and it should trip that boiler. But it won't trip the other boiler. The other boiler doesn't have a low water situation. It's going to stay online. If I just have gate valves, then now the boiler that's online is going to backfeed steam into the boiler with the tube failure. So even though that boiler has tripped, it's going to be billowing steam out of that leak and potentially making it very difficult to even enter the boiler room to shut the other boiler off, let alone to isolate the boiler that's having the issue and get it offline and do maintenance on that boiler. So a non-return valve becomes a safety device preventing backflow from a live boiler onto the boiler that is tripped and having the issue. It's a really good idea to do a non-return valve, even though it's not required. But I would say probably 98% of the installations we see where there's more than one boiler on a common system, non-return valves are the way to go, and that's definitely what we recommend. The one kind of one of the issues that we see from time to time though is it can be really tempting to just line size the non-return valve. What do I mean by that? Well, if the boiler steam outlet is 6-inch, then I must need a 6-inch non-return valve. Or if the boiler steam outlet is 10-inch, I probably need a 10-inch valve. And that's not really the case, because our burner turn down nowadays in modern boilers can be so high that can cause issues with the non-return valve if it's line sized. If I have a boiler burner that's 10-to-1 turn down, 10% flow through that non-return valve might not lift the plug and keep it open. And so what'll happen is when that boiler's at low fire, you'll hear the plug just banging on the seat, and you'll just hear the thing sit there and bounce. And that can damage that valve over time. So it's not uncommon to have the non-return valve be smaller than the boiler outlet. In fact, I would say it's probably typical to have it be smaller than the boiler outlet. How much smaller? Rules of thumb aren't really helpful here. You really need to have somebody that knows what they're looking at do a sizing. Again, it depends on the turn down of your particular boiler, where the sizes break for, should the steam outlet be the next size up or should the valve be the next size down. It's not something that I want to put a rule of thumb out there. You really need to have somebody that knows what they're looking at, or talk to the non-return valve manufacturer and say, here's my minimum steam flow rate and my maximum steam flow rate. Can you help me size a valve that will stay open at low flow but not provide too much pressure drop at high flow? So that's kind of the balancing act that we're playing with a non-return valve. Get open and stay open, but don't provide a whole lot of pressure drop to my system. I don't want to have to run the boiler at significantly higher pressures just to force it through this overly restrictive non-return valve.